let's find the volume of the solid that we're gonna obtain by rotating y equals c about the x-axis between x equals a and x equals b. We can assume that c is positive, okay, and we can make a drawing here. So this is our c, and x is gonna be between a and b. We assume that both a and b are positive for the clarity of this problem. Okay, in this case we have the area of the region. The region here that we have is, let me put this one here, y is equal to c. So this is our region here that we're gonna rotate to obtain our solid. We're gonna rotate this one about the x-axis, okay? And once we do, we obtain a let me do it here, a cylinder, okay? So we see that we obtain a cylinder, and the problem now is going to give us the volume of the solid, which is the cylinder, okay? So to do so, we need to use this formula here, that we know that the volume of the solid between a and b is going to be the integral between a and b of a of x dx. A of x is a cross-sectional area, and in this case it's a circle of radius c. Okay, so this is the radius here, because when we rotate we obtain the cylinder. Okay, so if we look from the top, we're gonna see something like this. So this is our c, and we see that's this is the cylinder here. Okay, and the x-axis is the one going through the center of the cylinder. Okay, so we know the area of the circle is pi times r squared, and r squared is just c squared. Okay, if we want to find the small volume, we can think of it as, in this case here, we can okay, this is our delta x. So this is a let me do it here. So it's gonna be some small cake, a cylinder cake, okay? Or we can look at this one from the side view. We're gonna see that we have it like this, okay? So this is my delta x, and this is and this is my c, okay? And this is the sectional area a, and when I multiply it by delta x, I multiply it by delta x, and for each point, if I sum up, I obtain this volume here. So I obtain v. Okay, so the key here is that once I keep adding these small volumes, I obtain the whole volume between a and b, and this is what we get. So the integral between a and b of a of x is pi c squared dx. Pi is constant, c is constant, so we have pi c squared between a and b of 1 dx. So this gives us pi c squared b minus a. Okay, so this is the volume. If we can think of b minus a as h, the height of the cylinder, and c as the radius, so we arrived at the volume is pi r squared h, and that's what we know from our elementary views of geometry and pre-calculus. So this is the volume of a cylinder having radius r and height h. Okay, so we use the calculus to get this result. Okay, the key idea is that we rotate this function here, which is constant, about the x-axis to obtain the whole volume. So we can draw it one more time here like this. So when we rotate, we obtain a cylinder, and we keep adding them. And once we add these cylinders, we obtain the whole the area of the cylinder. When we add those, the areas of the cylinders, which is the cross-sectional area of AX sub I, which is the center or of the radius of the cross-sectional area. When we add them, we obtain the volume. And that was the aim of this video here. So the volume in this case is pi c squared b minus a, and we can write it this way, and this proves the volume of a cylinder. Okay, if you have any questions or comments, please put them down or comment. Thank you.